Rational functions, page 3. For this time, we're going to have the degree on top bigger than the degree on bottom by 1. Degree of p equals the degree of q plus 1. The first thing we want to do when the degree on top is bigger is the long division. You learned about long division before. 2x squared goes into 4x cubed 2x times. Multiply it through 4x cubed plus 6x plus 2x. Do the subtraction. We get 6x squared plus 10x. Bring down the 5. And now we need to multiply 2x squared by 3 to get 6x squared. And multiply that all the way through, we get 9x plus 3. Do the subtraction, you get x plus 2. I also want to factor the denominator. So I'm factoring 2x squared plus 3x plus 1. That's going to get me 2x plus 1 times x plus 1. Now, I want to write g of x as the quotient, which is 2x plus 3, plus the remainder over the divisor. I'm going to put it in factored form. 2x plus 1, x plus 1. When I look at this and I think about what happens as x goes to plus or minus infinity, I know that for the fractional part, since the degree on bottom is bigger than the top, that is going to go to 0. We learned that on page 1. So all I have left then is 2x plus 3, which is what I'm going to put here. Or you could answer that g of x is going to the infinities since 2x plus 3 goes to plus and minus infinity. But I'm going to be more specific and put the equation. This tells me that I have an oblique asymptote of y equals 2x plus 3. We will put that in our graph below when we get to it. I can conclude that whenever the degree of the numerator is more than the degree of the denominator by 1, we will get an oblique, which is also known as a slanted asymptote. And I already told you what it is for this problem. We can get our vertical asymptotes the same way we have on our other examples, looking at the denominator and setting it equal to 0, and as long as that factor doesn't cancel, it creates an asymptote. So we get x equals negative 1/2 from the first factor, and x equals negative 1 from the second factor. Now I want to know when this graph crosses its own oblique asymptote, or its slanted asymptote. Well, when you look at the equation written in this form, you can see that it will be right on 2x plus 3 if we're adding 0. We add 0 when the numerator of the fraction is 0. Since the numerator is x plus 2, it's going to cross at x equals negative 2. All right. Now I want to figure out when this graph is above or below, not the x-axis. That would be helpful, but this would be hard to factor. So I'm going to see when it's above or below its own oblique asymptote. So I'm going to look at this remainder again, the x plus 2 over the 2x plus 1 and the x times the x plus 1. And I'm going to make a sign chart for the remainder. So we've got zeros from the top and bottom at negative 2, negative 1, and negative 1/2. And if I plug 0 in, which is to the right of negative 1/2, then I get 2 over 1 times 1. It's positive. And again, the multiplicity of each factor is just 1, so I'm going to alternate sign. And now I'm going to use my calculator as a little bit of a cheat. I'm not graphing the entire function, but I am going to graph the original numerator. I've already set that up in my calculator. I've got the equation. I've got the window set from negative 5.5 to 5.5 with an x scale of 1 and negative 20 to 20. I had to play around with it before I got that. And when I graph that, I get this thing. So let me just copy the picture, because if you were doing this on a test and you used your calculator to help you a little bit, I would expect you to copy the picture, at least a rough sketch. Negative 5.5 to 5.5 telling me the scale, and negative 20 to 20 telling me the window for the X and Y. And in here somewhere it's crossing, and that's really all I'm interested in, is where is that 0, since it's not one that's easy to calculate by hand. So I go to Second Calc and go to 0, and it's asking for the left bound. I go left of it, I hit enter. It's asking for the right bound. I go right of the 0 and hit enter, and the guess I just enter again. And it's at about negative 1.6. And that's all I needed the calculator for. Negative 1.6 is where it's crossing. So that's the only 0, because I know that the graph isn't going to be 0 unless the numerator is 0. For the y-intercept, you go back to the equation, g of x, and we got all zeros here and zeros here when you plug in 0 for x, and you just get 5 over 1. So the y-intercept is at 0, 5. Now I can use all this information to get an idea of what the graph looks like. So first I'm going to plot my vertical asymptotes. They're at negative 1 and negative 1/2. So I'm going to use kind of a large scale here so I can see that, so they don't look too close together. Negative 1, negative 1/2. X equals. All right, and then I also have the oblique asymptote at y equals 2x plus 3. If you set 2x plus 3 equal to 0 to find out where it crosses the x-axis, you get x equals negative 1.5. So I'm going to go here. If this is negative 1, negative 2 would be about here, about halfway in between. And then since I don't have a scale on my y-axis, I'm just going to slope up to represent a positive slope. And then we'll call the point where we crossed at 3. Okay? And then slope down. And that's so I'm going to be able to fit all the important details of the picture in. Now we also got a y-intercept of 5, so that's going to be slightly higher. That's for the graph itself. And what are we missing? Okay, we've got our asymptotes. We got, the graph crosses its own oblique asymptote at negative 2. So I'm going to draw right where I had labeled it, and I'll put the negative 2 above. That's where I'm actually on the oblique graph, is when x is negative 2. And now I can just use my sign chart to get the picture. We've got that when we are greater than negative 1/2, we are above our oblique asymptote, and we also got a point. And it doesn't cross anything else in that region, so I'll approach the oblique and approach the vertical and try to make the curve nice. That's that portion. Between negative 1/2 and negative 1, we got the graph as negative, and if that's all I knew, I wouldn't know whether or not it crossed the x-axis, but we already used our calculator to figure out that it doesn't cross the x-axis, so it's got to just be something like this. And then between negative 1 and negative 2, the graph is above the oblique asymptote, but we know it's going to come down here and cross the oblique at negative 2. And the one thing I forgot to put in the picture is negative 1.6. The graph crosses the x asymptote there, because that's where the numerator of the entire function was. I've got to approach my vertical asymptote, come down, go through the 2 known points, and then right here, on most calculators, it would just look like it's actually laying on the oblique asymptote, but we know it's not. It only crosses it. So I want you to show that crossing, and then I want you to come back and approach, because you always got to approach your asymptotes. That's going to create a little hump here, and I want you to show it even though if you graph the calculator at most zoom levels, you're not going to be able to see it. It is there, and it's a detail that you just can't see when you draw to scale. That's it.